Okay guys, in this video we're going to learn a little bit more about redox reactions, but more specifically we're going to talk about oxidation numbers. And it's a very important part of redox reactions is being able to determine what the oxidation number is for an element either by itself or in a compound. So a couple of things I would ask that you have out and have available. Your guided notes, Chapter 3 guided notes. I'll be filling those out as we go through. And also a periodic table. And also a polyatomic ion table will really help you. So let's get started. So redox reactions involve the transfer of electrons from one species to another species. So redox reactions involve the transfer of electrons from one compound or one element to another. Okay? So we've got to keep track of these electrons that are being transferred. And that's going to be the main focus of this video. So it will be important to learn how to track electrons from the reactant side of the equation to the product side. We will do this using oxidation numbers. Okay, so it's just a way to track electrons from the reactant side to the product side. And we call it oxidation numbers. And it's really not too bad, but I would ask that you pay special close attention as we go through this. It's not bad, but there's a few tricks. So let's first define what an oxidation number is. An oxidation number is the charge that each atom carries either in a compound or by itself. So oxidation number, it's really just the charge of the atom or the element in the compound. And so, in fact, they're used interchangeably. Oxidation number is the charge of each element, either by itself or in a compound. Now there's some rules for assigning oxidation numbers. Number one, free elements are 0. So if the element is just by itself, its oxidation number is 0. Number two, for ions, the oxidation number is the charge. So if it is an ion, the oxidation number is going to be equal to the charge. Rule number 3 is very important. Oxygen is always going to have a -2 oxidation number. I'm not going to ask you peroxide, so there is an exception if it's in a peroxide, but I'm not going to ask that. Let's just always assume for this chapter that oxygen's a -2. Hydrogen is always going to have a +1 for its oxidation number. And now there are exceptions with hydrogen as well when it's bound with a metal, but I'm never going to ask you a question like that. So oxygen's -2, hydrogen is +1. Rule number 4, in neutral compounds, the sum is 0. So we add up all the oxidation numbers, it better sum to 0 in a neutral compound. Now if it's a polyatomic ion, the sum is the overall charge. So if the polyatomic ion has a charge of a -2, then it sums to a -2. Okay? And always, group 1 elements are going to have an oxidation number of +1. So group 1, the alkali metals, they're going to have an oxidation number of +1. And group 2, the alkaline earth metals, are always going to have an oxidation number of +2. Okay, so if we can remember those 6 rules, this will be pretty easy. Okay. So let's go through each one of those rules kind of individually. Rule number 1, it said that free elements are 0. So for example, hydrogen is, in this example, H2 is just by itself. So it's going to have an oxidation number of 0. And I always write the oxidation number above the element so that you know what its oxidation number is, 0. Magnesium, it's not a cation in this case, it's just pure magnesium. It's a free element, it's 0. Sulfur, even though there's 8 of them, it's still by itself, it's 0. Chlorine, There's two of them, but it's a free element. It's by itself. It has an oxidation number of 0. So in each one of those cases, it's going to be 0. Okay, let's go to rule number 2. For ions, it is the charge. For example, sodium chloride now is a compound. It's not an element just by itself. Chlorine and sodium. Sodium is a group 1 element. It's an alkali metal. They always are +1. Okay, and since there's just one of them, chlorine has to be a -1 because it doesn't have a charge here. The charge is 0, so it's got to sum to 0. So sodium's oxidation number is +1. Chlorine's oxidation number is -1 in this case. Potassium, +1. This cation, again, for ions, the oxidation number is the charge, so it's just going to be +1. Now we've got this compound, magnesium chloride. Magnesium is a group 2 alkaline earth metal. They always are +2. And it's got to sum to 0 because there's a 0 charge here on this compound. And so the chlorine, if this side's +2, this side's got to be a -2. But there's two of them here. So each one has got to be a -1. And so the oxidation numbers are +2 for magnesium and -1 for chlorine. Okay, it looks like we got those right. Let's go to rule number 3. Oxygen is always a -2. Hydrogen is always +1. Actually, rule 3 is probably the best rule to remember and go off of first. Oxygen, if you have oxygen in it, it's a -2. Hydrogen, it's a +1. Okay. So let's do an example here. H2O. Well, oxygen's going to be a -2. I've got one oxygen atom, so that's a total of -2 on the right side. Hydrogen's always +1. There's two of them, so that's +2, which will sum to 0, and water doesn't have a charge, so that's the case that it needs to be. So hydrogen is +1, oxygen is -2. Now what if you have something like this? We've got 3 elements here. Well, if you see oxygen, always just put a -2 above it. -2, we've got 3 of them though, so that's a -6. I can't tell what sulfur is right now, but I do know that sodium is a group 1 metal. Group 1 is +1, but I've got 2 of them, so that's +2. Now, this compound doesn't have a charge. Its charge is 0, it's neutral. So that means it's got to sum to 0. So sodium's +2, oxygen's are -6. What does this sulfur have to be so that it sums to 0? And if you do the math on that, that's going to be a +4. Okay, so sulfur is +4. Okay, now we've got an example where there is a charge over here. The sulfate ion is polyatomic and it's got a -2 charge. But always oxygen's -2 times 4 is a -8. Well, we know that this has to sum to the charge, which is a -2. So what does sulfur have to be in this case? To get to a -2, we already have a -8. This better be +6. Okay, and so these are my oxidation numbers. -2 for oxygen, +6 for sulfur. Okay, now let's see if we got this right. Hydrogen is +1, which we got. Oxygen is a -2, which we got. Sodium is +1. Sulfur is +4. And oxygen is -2. Sulfur in this case is +6. And oxygen is -2, so we were right. Okay, let's go to another rule. Rule number 4. It says in neutral compounds, the sum is 0. If a polyatomic ion, the sum is the overall charge. So let's go through a few examples. And actually, we just talked about this. This one, the oxidation numbers have to equal 0. So -2, but there's just one, so it's a -2. Hydrogen's always +1, but there's 2, so that's +2. So it sums to 0. This one would have to sum to a -2, and we just tried this example, so I think we'll just move on. Okay, I've got a number of practice problems for you to try. So please, let's try them. I think in each case, it works better if you will try them first. So if I were you, try them first and then hit pause and try them first, and then hit play and see if you got it right. It says to assign oxidation states or numbers to all the atoms in carbon dioxide. So please hit pause, try it on your own, and then once you have an answer, hit play and see if you got it right. Okay, so let's see if we got it right here. Oxygen, always, rule number 3 says oxygen's always a -2. We've got 2 of them though, so that's a -4. Carbon dioxide doesn't have a charge, so it's got to sum to 0. That tells us that this carbon's got to be +4. There's only one of them, so it's +4. So carbon, in this case, has a +4 oxidation number, and oxygen's oxidation number is a -2. Hopefully that makes sense. Okay, and we got that right. Let's go to practice problem number 2. It says to assign oxidation states or numbers to all the atoms in this molecule. Okay, please try it on your own. Hit pause and try it and see if you got it right. Okay, let's see. Here, fluorine and sulfur. Okay, we know that fluorine is going to have a -1 charge. It's a halogen, but there's 6 of them, so that's total of a -6. We know that it doesn't have a charge, this molecule, so it's got to sum to 0. So that tells us that the sulfur has to be +6. There's only one of them, so it's +6. So in this case, sulfur's oxidation number is +6, and fluorine's oxidation number is a -1. Okay. And we got that right. Okay, let's go to number 3. It says assign oxidation states or numbers to all the atoms in this. This is a polyatomic ion, it's nitrate. But remember, it's got a -1 charge, so it better sum to a -1. So hit pause, see if you can get the oxidation numbers for oxygen and nitrogen, and then hit play when you have your answer. Okay, let's see if we got this one. Oxygen's always a -2. There's 3 of them, so that's a -6. So what would nitrogen have to be if it's going to sum to a -1? Well, it better be +5, because +5 minus 6 is a -1. I always write the oxidation number above the element here. So nitrogen is +5, and oxygen is always a -2. Okay. Hopefully you got that right. Okay, I've got a few more here for us. So practice problem number 4. It says to assign oxidation states or numbers to all the atoms in this polyatomic ion. This is called sulfate, and it's got a -2 charge, so that tells us it better sum to a -2. So please hit pause, try it on your own, see if you can get the oxidation numbers for oxygen and sulfur on your own. Okay, let's see if you're right. Oxygen is always what? Well, it's always -2. Times 4 is a -8. Now, if this thing has got to sum to a -2, what does the sulfur have to be? And hopefully you put +6, because +6 minus 8 is -2. So sulfur is equal to a +6, and oxygen is always -2. Okay, and we got that one right. Let's go to practice problem number 5. It says to assign oxidation states or numbers to all of the atoms in this compound. We've got sulfuric acid right here. So this one's a little more complicated in that it has 3 elements. We've got hydrogen, sulfur, and oxygen. And it doesn't have a charge, so we're going to sum this to 0. Okay. Okay, so let's see if we got this right. We've got oxygen, which is always a -2, and we've got hydrogen, which is always a +1. And so if we do the math on this, a -2 times 4 is a -8. And the hydrogen is +1 times 2 is +2. So now all we have to do is figure out what the sulfur is in this case. But we know that it sums to 0, so +2 and -8, what's left? is a plus 6. So 2 plus 6 is 8, minus 8 is 0. So this would have to be a plus 6. So hydrogen is always plus 1. The sulfur in this case is plus 6. And the oxygen is always a minus 2. Okay. So hopefully that makes sense, and hopefully you're starting to get these right. But I've got a couple more that are a little more complicated now. So let's try and see if we can get these ones. Practice problem number 6 says to assign oxidation states or numbers to all of the atoms in this polyatomic ion. Okay, so before I let you try it on your own, it's got to sum to a minus 2 because it has a minus 2 charge. Okay, please hit pause. Try to get oxygen's oxidation number and chromium's oxidation number, and then hit play. Okay, let's see if we got it right. Oxygen is always minus 2, and we got 7 of them, so that's a minus 14. So that tells us what has to be right here in order for it to equal a minus 2. And the answer is plus 12. Because plus 12 minus 14 is a minus 2. But in this case, we've got 2 chromiums here. So what times 2 is equal to 12? And the answer to that is plus 6. So chromium has the oxidation number of plus 6. Oxygen has the oxidation number of minus 2. Okay, a little more complicated there, so hopefully we got that one right. I think I've got one more practice problem with this, and then we're done. So let's see. And we got that one right, so good job. Okay, practice problem number 7. Assign the oxidation states or numbers to all of the atoms in this compound. Okay, aluminum nitrate. When you look at aluminum nitrate, it's a little bit intimidating. It's got 3 different elements, and we've got parentheses here with a 3 on the outside. So let's just break this one down and see if we can make it as easy as possible for us. What I like to do when there's polyatomic ion is to break it up. Okay, if we look at NO3, and if you look at nitrate's charge, nitrate has a charge of a minus 1 by itself. But how many do we have? Well, we have 3 of them. So if we were to separate this, that would be a minus 3, because there's 3 of them, that would be a minus 3 total on the right side. That means the aluminum would have to be plus 3. I have a plus 3 charge. Okay, and so we already know aluminum is going to be plus 3. The oxygen is always minus 2, but I've got, let's see, I've got 3 times 3, which is 9. So a minus 2 times 9 is a minus 18. And so the nitrogen here, I've got 3 of them. Okay, don't forget that the 3 on the outside gets distributed to everything on the inside. So I've really got 3 nitrogens here. What number has to go here so that it sums to 0? And the answer is plus 15. But I've got 3 of them, so each one has to have a plus 5 charge. And so that's kind of how I go about figuring that out. So the oxidation number of oxygen is always a minus 2. Nitrogen, in this case, is going to be plus 5. And aluminum is plus 3. Okay. And so there's my answers. Now that's how if you didn't want to separate it like that, let me show you another way to do this problem. Okay. And so we know that this compound doesn't have a charge. It sums to 0. Okay, let's just figure this out. So oxygen has a minus 2 charge, times 3 times 3 is 9, so there's a minus 18. We don't know what the nitrogen's oxidation number is right now, but we know that the aluminum is plus 3. So plus 3 times 1 is plus 3. And so that means that this has to be plus 15 overall. 3 plus 15 is 18, minus 18 is 0. But I've got 3 of those nitrogens, so each one has to be plus 5. Anyway, a couple of different ways to look at that one. And hopefully that makes sense. Let's see if we got it right. Plus 3, plus 5, and a minus 2, which we did. Okay, this is the last slide in this video. I just wanted to quickly show you that a lot of elements have more than one oxidation state. So that's why it's so important to be able to determine what the oxidation number is. For example, sulfur in this compound is plus 6. In this one, it's plus 4. All by itself, it's 0. In this case, it's a minus 1, and in this case, it's a minus 2. So 1, 2, 3, 4, 5 different oxidation states for sulfur. Carbon has 3 different ones. Nitrogen has a bunch. Iron, manganese is a very interesting element because all of its oxidation states that it has, you see manganese in a lot of minerals. Well, each oxidation state in the mineral corresponds to a different color for that. So manganese minerals can be, from purple to pink to blues and greens. And that's what makes such interesting colors when you're looking at the mineral and with manganese in it. But copper, tin, uranium, arsenic, chromium, gold, all of them have more than one oxidation state. So please use the rules. There are 6 rules. If you use them, and it takes some practice, but we can assign an oxidation number to each element in a compound. So hopefully that helps. I've got some more practice problems for you. In the student workbook, there is a worksheet that's titled Oxidation Numbers Worksheet. So please go to your student workbook and turn to Oxidation Numbers Worksheet and complete that and try to. And again, if you need more help, please stop by, but I hope this video helps you.